Hello students, good morning to all of you. Okay, now till now we will study about the exercise 8.1 in chapter 8. Okay, now today we will learn solving the problem of the exercise 8.2. For that, first of all we will learn basic two theorem on this. Okay, what are the theorem? You can see on the screen here right now. Theorem 8.9. What is this theorem says? This theorem says that, listen carefully. The line joining to the any triangle, midpoint of the triangle. What? Line joining to the midpoint of the triangle. First of all, here they gives that any triangle ABC. Okay. The line joining to the midpoint of the triangle, any two side. Okay. First of all, I am taking this side, AB. This is the midpoint D is of the line segment AB, and E is the midpoint of AC. Okay. Now joining this midpoint, okay, and this line is exactly parallel to the another line, means DE is parallel to BC. Okay. And one more thing you remember for more question solving, that DE is always half of the BC. Always remember it. Okay. You just remember this some basic funda to solving problems of the exercise 8.2. Okay. Understand what I am saying that? Okay. Here DE is parallel to BC. Okay. And DE, the length of this side is exactly half of the base. Okay. Now, another theorem. What is another theorem? Another theorem 8.10 says that what 8.10 theorem says? Exactly converse theorem is that. What this is that if any line, you can see on the screen on triangle ABC, okay, if any line passing through any midpoint of the side, any one side of the midpoint, so suppose I am taking a midpoint D of this side. Okay, if I am drawing a line is parallel to BC, okay, now that line is intersecting the side AC, another side, and bisect it. What? Bisect it means कोई एक side है, okay, any one side. Now from any one side I am taking the midpoint and line from this midpoint, if and which is parallel to another side, and that line intersecting the third side of the triangle bisect each other, means here AE is equal to EC. Okay, or you can also say that E is equal to half of the AC. Okay, also you can say that it is the midpoint, means nothing else but the converse theorem. Okay, now if you have the clear about these two theorem, then you can solve the question of the exercise. Now today we will solving some basic question 1, 2, 3, 4, and further question I am giving you for the homework. If you have any doubt, then ask me. Okay, so solving the first question, I have some question in this book. I have no book, so I just use the soft copy. What is the question number 1? You can see on the screen. Okay, what is the question number 1? ABCD is the quadrilateral in which PQRS are the midpoint of the AB, BC, CD and DA respectively. AC is the diagonal, shows that. Okay, what this is that here? ABCD is the quadrilateral. Any quadrilateral here like this. A, B, C, D is a quadrilateral of which PQRS are the midpoint of AB, means PQ is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD and S is the midpoint of AD. Now joining this. Okay. AC is the diagonal. AC is the diagonal. Diagonal shows that, what shows that first? Means SR parallel AC. So first of all, what is here given? What is here given? What is given? Here given quadrilateral ABCD. Okay. And what they say is that midpoint. What? Midpoint. P, Q, R, S are the midpoint of AB, BC, CD and AD. Nothing. They are given. What to prove? What to prove? SR parallel AC. They given the question. So you just write here SR parallel AC and SR is 1/2 of AC. Okay. Then PQ. What is second proof? PQ is equal to SR. What is third proof? PQRS is the parallelogram. PQRS is a parallelogram. We want to prove this thing. Now, how to prove it? Okay. Now you just see how to prove it. Okay. Here, quadrilateral ABCD, PQRS are the midpoint. Okay. What we first prove? SR. Here, what is SR? SR is parallel to AC, and SR is 1/2 of AC. Now here triangle, first of all we will take a triangle ABC and triangle ADC. What we take? Triangle ABC. Okay. Now here you just see here. For any triangle we will prove that. For triangle A, D and C. Now you see R, S and R are the midpoint of AC, AD and CD. Means S और R हमारे क्या है? Midpoint है. This is a triangle. What we have learned है, if line passing through the midpoint of the two sides is exactly parallel to AC. Okay. So from theorem 8.9 we will know that. Okay. 8.9 from theorem. Okay. Basically 8.9. What we know that? Here SR is parallel to AC and SR is half of the AC. Okay. We will already know that na? In theorem 8.9. So already prove it. Second proof. PQ is equal to SR. Now, here taking triangle ABC. Similarly, ABC. What you can say that P and Q are the midpoint of AB and BC. P and Q मेरे कैसे है? AB और BC के मिड पॉइंट है. ओके, तो सिमिलरली फ्रॉम थियरम 8.9, what we can say that PQ is equal to half of the AC. Okay, but we know that from equation 1, PQ is equal to what are half of the AC? Half of AC is equal to SR. So already we can prove this. Now says that PQRS is a quadrilateral. What this is that PQRS is a parallelogram. Okay, what here we want to prove that parallelogram. So we already know that PQ is equal to SR. In parallelogram, what we know that in parallelogram, opposite sides are parallel to each other. Opposite sides are parallel to each other. Okay. So similarly, I am just here already we proved that. Here already we know that. What we know that, I just do here. What we know that PQ is parallel to SR. Already we know that here. Or you can also say that PQ parallel to AC and AC parallel to SR means PQ parallel to SR है ना. PQ AC से parallel है. ओके, और SR भी AC से parallel है. Similarly, equation I take 2. Okay, equation number. Similarly, okay. What from theorem 8.9. Similarly for here, triangle, I just take like this. Triangle A B D. Okay, from triangle ABD, PS is parallel to BD. Okay, and from triangle BCD. Okay, BCD. What we know that RQ is parallel to BD, means PS parallel to BD and BD parallel to RQ. So means PS parallel to RQ. That is equation number 3. So from equation 2 and 3, opposite sides are parallel, है ना. PQ parallel to SR and SPS parallel to RQ. PQRS is a parallelogram. Okay, just note down it. I hope you can see, or if you can't see, then I just down my cameras here. Sorry, student. Now you can see the whole question. Question number 2 in exercise 8.2. What is the question? ABCD is a rhombus and PQ, R and S are the midpoint of the AB, BC and CD respectively. So here they given that it is a rhombus. Rhombus means all the sides are equal, A, B, C, D. Okay, then respective point P, Q, R S. Okay. A, B, C, D is the rhombus. Okay. So first of all, what is given here? Here they given that AB is equal to BC is equal to CD is equal to AD due to rhombus. And what to prove? And also says that P, Q, R, S are the midpoint. Okay. Prove. What to prove here? Shows that PQRS is a rectangle. Now, how to prove it? Okay. Proof. How to prove it? Okay. Now you just see here. To prove the PQRS is a rectangle, okay, we want to prove that the length of the diagonal are equal. Okay. It means what we want to prove that PR is equal to SQ. Okay, because in the rectangle, okay, diagonal have the equal length. Okay, so here we want to prove that PR is equal to SQ. So how to do? So here similarly what we do? Here we will take two triangles. Okay, so here we know that for triangle ABC, for triangle ABC, okay, according to theorem, what happened? According to theorem, what we say is that, okay, PQ is equal to half of. Now tell me how we solve it. Okay, how we can solve it? Just tell me. Anyone have an idea? So first of all, here we want to prove two things. Okay, what are the two things? Here we prove that PQ is parallel to SR and PS is parallel to RQ. If this condition we can prove that, then we can say that this is a rectangle. In rectangle, what are the conditions? The conditions are the opposite sides are parallel. So means PQ parallel to SR and PS parallel to RQ. This condition. And what is the another condition? Another condition is that the diagonal have the equal length. If we can prove this thing, then we can say that. So here PQ is parallel to AC. Okay. And for triangle ABC means SR is parallel to AC. So PQ parallel to SR means PQ parallel to AC, SR parallel to AC means PQ parallel to SR. Understand? Similarly, I take this diagonal. Okay, same theory, same thing we will do for triangle A, B, D. Okay, PS parallel to BD. Okay, and similarly for triangle, same theory, BCD. Okay, what? QR is parallel to BD means PS parallel to RQ or QR. So I already proved these two conditions. Okay, this is the condition 1, this is the condition 2. I already proved. Now we will want to prove that PR is equal to SQ. Now, here it is a rhombus. Okay, so for I just take track quadrilateral. Here quadrilateral. Also say you can see the parallelogram. Parallelogram PRCB. PRCB is a parallelogram. Means PR is equal to BC. Okay, and similarly triangle, I just take that quadrilateral, sorry, SQBA. Means what I want to prove that this equal to this. Okay, this equal to this, but we know that here is the rhombus, this equal to this. So also we can say that parallelogram SQBA. So what is a parallelogram? Means what happened? SQ is equal to AB, but here we know that it is a rhombus. Okay, here AB is equal to BC. Why? Rhombus. So what we can write here? Here we can write that AB is equal to BC, means PR is equal to SQ. PR is equal to SQ. Okay, so diagonal of PQRS is equal. So diagonal of the PQRS is equal, and PQ parallel to SR, PS parallel to RQ. So PQRS is a rectangle. Now you note down it.